And we're finally here, the most exciting topic of the day. This is what we learned nested loops and 2D lists for, and you'll see why in a second. Now we're going to talk about images. The reason this is so exciting is because images are the primary way that you and I interact with our devices. We're not just talking about taking images here. We're talking about the very screen on your phone or computer. When you're watching this right now, you might not realize it, but what's being shown on the screen is just one big image. And the way that stuff moves around, or when you move your mouse, is that the computer keeps drawing a new image each time. It's kind of like animation. If you watch any Disney movies or any old cartoons, where each frame is hand drawn, and then when you put a whole bunch of frames together and move through them really quickly, it looks like a video. It looks like there's motion happening. The same thing happens on our screens. When you move your mouse, when you change something, when you type something, the whole screen gets redrawn with a new image. And so now we're finally learning about images, which are very applicable to just everyday lives and the way we interact with our computers. Let's start off with the simplest kind of image, a black and white image. Not even just gray or any other color, like just black or just white. So here we have this little guy. Bonus points, bragging rights if you can recognize who this is. It's my Android figurine. This is an example of a black and white image. Everything here is either black or white. And I'm going to zoom in a little closer. Enhance. Okay, this is kind of interesting, by the way. So starting to look here, notice, it looked kind of smooth out here, these smooth edges, but, as I zoom in, okay, it's a little bit blocky. Oh, that's weird. It's definitely supposed to be rounded, but can I zoom in even further? Okay, actually, wow. This isn't even a straight line here. This is rounded. It's really blocky. Why is that? Well, actually, what's happening here is if you zoom in super close on your computer, if you could look really close on your monitor, you'll notice that everything on your screen, all of images, are made up of pixels. And these pixels are these kind of squares that any image is broken down into. So an image is a grid of pixels. For a black and white image in particular, each pixel can either be 0 or 255. So it's a level of brightness. We're going to say for now, black and white images, either 0 or 255. So 0 is our lowest brightness. So when something is not bright at all, it's dark, it's black, the lights are off. And 255 is the highest brightness. So the sun, super bright, light, white. So if I just put numbers in here, you'll be able to see a little more clearly. This pixel here, the square in our grid is 255 because it's white. All of these pixels are 255. And each of these squares are represented by a 0 because they're black. So lowest kind of brightness. Now, how is this actually represented in memory or when we work with it in our programs? Well, this word grid should look familiar from this lecture. We actually represent this as a list of lists, a two-dimensional list, where each entry in our list is itself a list of pixels. So effectively rows. So you can see here, the image is a big list where the first entry in our list is a row of pixels, which is the first row in our image. The second entry is a row of pixels, so on and so forth. So notice here that this is the same layout that I showed for our classroom example earlier today, where the top left corner of our image is pixel 0, 0. Because if we index into our image, first we get row 0, and then we get kind of value 0 in that row. It is the top left corner of our image. And so the top right corner of our image is going to be row 0, and then pixel, whatever the width of our image here is, which is 10 pixels wide, so 9 because we start counting from 0. Whereas the bottom left corner is the height of our image, which is here 10, so index 9, comma 0, because this is the 10th row and the first item in that row. And finally, with height is the bottom right corner. So given that, let's write a quick function with this knowledge. Let's write a function to invert a black and white image. So we'll come back here and we're going to take in an image of some sort. Def invert image, and we're representing our image as a two-dimensional list. So let's call it pixels. It's a two-dimensional list of pixels. So what are we going to do? Let me make a sample image here. Pass. That's what our image looks like. So the first row is going to be 0, 0, 255. The second row in our image is going to be 0, 255, 255. And the third row is going to be 255, 255, 255. So by the way, if we were to visualize what this looks like, it would be kind of this triangle, right? So 255 is the brightness. So it would be a black triangle in the top left corner and a white triangle in the bottom right corner. So how do we invert this image? So given a two-dimensional list of pixels, we want to iterate over each pixel and make some change to it. So how do we do that? We first need to get our rows. So for row in length in range, what should our range be here? Well, you might be tempted to say 3 because you're right, there are 3 rows. But let's do this in a programmatic way. Let's say that we're going to do range length of pixels. So it'll work for any size image that we pass in. Okay, now what about for column? So this gives us, for each row, do something. Yeah, what about for the columns here? So we're going to use another for loop, a nested for loop for call in range. What should our range be for columns? Well, how many columns do we have? Yes, we have 3 columns. That's pretty clear. There are 3 items in this list. But again, for this to work for any possible two-dimensional list that we pass in, we want to go through each item in this row. So we should do the length of the row. And you know what? I'll just be very clear here and call this a row index. This is a column index. So for column index in range length pixels call index, we'll do something. Oops, row index. Pixels row index. This will get us the particular row that the outer loop is referring to. So row index, pixels row index. And then it will iterate over the indices that are valid for this particular row. So now we have a particular pixel, and we can do print pixel, and we'll do stir row index. So row, comma, call index has value, and then we'll do the value of this pixel. So the way we do that, how do we get the value of our pixel? We're going to do pixels, and which row do we want? We want the row at row index. And then we want to index into the particular column in that row. So call index. And now if we run our code, python3 main.py, whoops, yeah, we didn't actually call our function here. So let's call our function. Image given a particular image. So pixel 0, 0 has value 0. Good. 0, 1 has value 0. 0, 2 has value 255. Okay, 0, 0, 255. 0, 255, 255, 255, 255, 255. So now we go and we want to invert the image. So what does inverting the image means? It means that whenever we see a 0, we should make that 0 255. And whenever we see 255, we should make that 255 a 0. So that sounds like conditionals to me. So the way we get the value at a particular pixel is like this. Pixels, row index, call index. So if the value there is equal to 0, then we're going to assign a new value because our list is mutable. of 255. Otherwise, that means that the value must be 255, and so we will assign a value of 0. And for good measure, let's just return the pixels at the very end. We'll do print image. If I run this, oops, I didn't actually call the function here. And I'll comment out this line 14 so it doesn't bother us. So what we get back is 255, 255, 0, 255, 0, 0, 0, 0, 0. And you know, this seems pretty reasonable. If I just make this more visually appealing, like this. Oops. This is indeed the inversion of what we had up here. So we had the exact opposite up here. 255, 255, and then all zeros. Great. Now I'll point out one more thing. We actually don't need to return anything here because we're modifying the list that's being passed in. So I can just print out the resulting image, and the resulting image should have changed. So first we have to call our function, of course. So invert image given the image. And then if we print out our image, you can see it has changed. And if I print it before, we can see before it was 0, 0, 255, then it becomes 255, 255, 0. Again, this is because lists are mutable. Lists are mutable. So when they're passed into a function, if you make changes to them, the actual value gets updated. So here's that same code that I just wrote.